This is chapter 5B. We just had chapter 5A. Chapter 5A, we identified linear functions. We figured out what the equations would look like. We then examined the rates of change of linear functions, which is the slope. We figured out multiple ways to calculate the slope of a linear function. And we graphed, and that was it. Simple. Chapter 5B is a little more complex, but it's still dealing with linear functions. So all of the equations that we're going to be dealing with, all of the graphs that we're going to be looking at, all lines. We are graphing something that looks like a U or a V or something curly or anything, we're probably not graphing the correct thing. Okay? So what I want you to do right now is I gave you an equation, y equals 1/3 x plus 2. I want you to find the x and the y intercepts of that equation, and I want you to then find the slope using those two intercepts. And then I want to graph the x and the y intercepts, and I want you to connect and extend. X-intercept, of course, has the y-coordinate of 0. Y-intercept has an x-coordinate of 0. Dividing by 1/3 is the same as multiplying by what? Yes. Show your work, Mr. Freeman. Do every single step. It has to be negative. Show all your work if you're not getting it by just looking at it. Once you found your 2 points, those are good. Use those 2 points to find the slope between those 2 points. You can either do it by graphing and then going rise over the run, or you could just do your changing your y's or you're changing your x's. Whatever. Make sure when you do your change in y's divided by the change in your x's, you got y minus y1 over x minus x1. Y2 minus y1 over x2 minus x1. Make sure you're careful about the signs. Try your x-intercept again. You have to do some math here. That one again. Good. You plug in 0, you just get y equals 2.
Oh, okay.
That's it. But here, you get just positive. Why'd you get positive? You should get negative 2, because it's negative 2 times 3. You guys are not showing all of your work. Show all of your work. Do all the steps. X-intercept when y is 0. plug in 0 for y, solve for x. You don't manipulate your equations. You don't have to move stuff around. You just plug in a point, and you find the other half of the point. I have to subtract 2. You get negative 2 equals 1/3 x. Then to solve for x, I multiply by 3. I get x equals negative 6. Which I can plot. 1, 2, 3, 4, 5, 6. Negative 6, 0. For the y-intercept, I plug in 0 for x. This one's easy. Y is equal to 1/3 times 0 plus 2. Y just equals 2. 0, 2. Everybody check to make sure you got the same intercepts as I did. After plotting those 2 points, you can connect and extend to show the solutions, all of the solutions to y equals 1/3 x plus 2. Step 3 was to find the slope between those 2 points. If you didn't find the slope, find it now. And make sure you are doing, if you do this y first, this x needs to be first. Or you could do rise over run between your 2 points. Just find the slope correctly and simplify it. Y's over your x's. Do it again. Y's over your x's. This is not 0, this is 2. Simplify it. That's fine. Just simplify it. That's not right. Do it again. That's not right. Do it again. Do it again. y2 minus y1 over, you got to use this x first if that y came first, x2 minus x1, I get 2 over positive 6, which is 1/3. That's the slope, not negative 1/3, positive 1/3. Well, what do we notice about the equation and the information I found? This is a linear function, yes. But I found the x-intercept, I found the y-intercept, and I found the slope. And those x, y, and slopes came from this equation. What do I notice? Stuart, do you notice anything? Nothing? No? I just want to look at these 3 things, Miss White. This, 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 and look at this at the same time. Do you see anything, Miss White? I'm asking you, Miss White.
You were consistent in the way that you always did.
It's not about how I got my answers. It's about looking at the answers and looking at the equation. Ms. Stewart, do you notice anything? What about the 1/3? Yes. And it shows up in my equation. The slope is in the equation. We'll talk about it. What else? Mr. Suarez? The y-intercept is in the equation. We found that the slope is 1/3. Look at that. Slope's 1/3. We found the y-intercept was 2. Well, look at that. The y-intercept is 2. This brings us to the slope-intercept form of a linear equation. All lines, all equations of lines, can be in the form y equals your slope times your variable x plus your y-intercept. Y equals mx plus b. Why we split chapter 5 into 2 different parts? Well, kind of. You know, like the first part was just looking at slope and just looking at lines in general. Part 2 is kind of like being able to look at lines more quickly, be able to produce equations of lines given information, produce parallel lines, perpendicular lines, transformations of lines. So, kind of. M stands for the slope. We use the slope formula, m equals y2 minus y1 over x2 minus x1. Well, here it is, m, right there. It's a number. B is the y-intercept, where my graph crosses the y-axis. Well, without a calculator, without struggling to find points, equations can be easily graphed if I know the slope and the point. If I wanted you guys to graph y equals 3/4 x minus 2, what you would do as of last class, which was the test, is you would just find 2 points that worked, right? And some points would be easy to find, some would be difficult, and some would end up being fractions. Well, watch this. I can graph 1 point, my y-intercept. 0, -2. That's 1 point. I can graph a second point by applying the slope to that first point. The slope is 3/4. That's a rise of 3 and a run of 4 between 2 points, or it's a rise of 3/4 to a run of 1. I can either go rise 3, run 4, or rise 3/4, run 1. Now, if I rise 3/4, run 1, I'm at a decimal location. So I don't want to do that. Instead, I'll rise 3, run 4. I go up 1, 2, 3. That's a rise of 3 from that point. Then I run 4. 1, 2, 3, 4. I get to the point 1, 4. Now, it's going from your first point to your second point. You're not starting from like the origin or any. You start from your first point, travel to your second point. Now, to check to make sure this is correct, this is the point 4, 1. I can go into my original equation and make sure it works. If y is 1, is x 4? Well, 3 times 4 divided by 4, that's 12 divided by 4, that's just 3. The 4's cancel. 3 minus 2 is 1. That works. So we just found 4, 1 by applying the slope. Once we have 2 points, we are good to connect and to extend. I went up 3 and over 4 from my first point. My first point was 0, negative 2. Going up 3 brought me to 1. Going over 4, 1, 2, 3, 4, got me to 4, 1. I could do it again. I could go up 3. So up 1, 2, 3 would take me up here to 4. Over 4 would take me over to 8. So this point right here would be the point 8, 4. Just by applying slope to previous points. I'd then check with the original equation and it would work. Okay? So now we have an easy way to graph equations if they are in this form, y equals mx plus b. So let's practice that. Here are 2 equations. I want you to graph these equations quickly by finding the y-intercept, graphing it, and then applying the slope. Yes. If the slope is negative 3, you can write it as negative 3 over 1. Six is your y-intercept. 1/3 is your slope, which is your rise over your run. Graph your y-intercept, apply the slope to that first point. You will get a second point. Once you have 2 points, you're good to go. Connect and extend after you graph the 2 points. That's up 3 over 1. My rise is 1. My run is 3. No need for x-intercepts, just a y-intercept and a slope is all you need. 0, 6 is your y-intercept. All right, 0, 6 is my first point. Mr. Lacey, can you tell me the next point that you graphed that you know works in your equation? Did you graph the equation?
I graphed it.
And that's it. Okay. Mr. Maurer, could you tell me the second point that you used when you graphed your equation?
3, 7.
3, 7 is correct because you traveled up 1 over 3 from one point to get your second point. Let's make sure we're paying attention. Zero, 6, 3, 7. I plug in 3 for x. I get 7. So it worked. Let's do it for the other equation if we haven't done so yet. Graph the y-intercept, apply your slope. Then go ahead and label both points using x's and y's. Don't just plot the point and just forget about it. What's the slope? It's -3, right?
Yeah.
How can I write it as a rise over a run?
I just went down 3.
I know. But you got to run something, right? Because it's not -3 over 0, is
So
it?
it's D1.
Exactly. So it's -3 over 1. So you got to go down 3, but then you got to go to the right one. Make sure you know where that point is located. That's your first one. Find your second one. Okay. Down 3 over 1, right? Down 3 over 1. Find where that point is located. Mr. Coburn, what was the first point that you plotted?
0, 1.
Good. Mr. Bladen, what was the second point you plotted? 1, -2 is correct. To get 1, -2, you go down 3 to the right 1. Now, can I go up 3, left 1? Why is up 3 and left 1 the same as down 3, right 1? It is an extension of the line, but it's important to realize that -3 can be written as -3 over 1, or what? 3 over -1. So I could go up 3, left 1. Just like 1/3 could also be written as what? Nope, -1/3 and 1/3 are not the same. Aha, -1 over -3 is the same as 1/3. So if I wanted to, I could have gone down 1 and left 3. Down 1, left 3 would have gotten me to -3, 5. Up 3, left 1 would have gotten to -1, 4. Okay, so we can apply the slope in both directions, to the right and to the left. Just if we go to the left, we got to make sure if it's a positive, it's a negative over a negative. All right, well now, since you have this knowledge of the slope-intercept form of a graph, I could give you information about an equation, and you can give me the equation with said information. Like if I ask you, hey, I want to know the equation of a line that has a slope of 3/4 and a y-intercept of -2, Mr. Dollar, you'd be like, yeah, Mr. Messner, I got it. The equation is what? Exactly. Piece of cake. Right, Mr. Dollar? So tell me what the second one is.
Y equals 2x plus 4.
Yes, it would be -2. And that's it. Why don't we write that down, Mr. Dollar? Keep our head up in class. Mr. Maurer, question.
For the first one, couldn't we also put y equals 3/4 x minus?
Of course, Mr. Maurer, you know that's the same.
no, maybe not for this equation.
No, it is. It is. Plus the negative is the same as subtracting a positive. All right, what about the last one? Mr. Conwell, what do you think? Yeah. Correct. Can you simplify that, Mr. Conwell? Yep. You guys now have the power of knowing information, and then you are able to give me equations. You have the power. Well, guess what? The power is great and all, but what if I give you an equation like this? 3x plus 2y equals 7. And what if I ask you to find the slope and the y-intercept of the following equation? Well, sure, you can find 2 points and you can find the y-intercept by plugging in 0 for x. But we also can do something else, knowing that y equals mx plus b is the slope-intercept form, so that we can discover this information. Mr. Sharma, what can we do?
You could put it into slope-intercept form.
Exactly. We can solve for y to make this equation a slope-intercept form of an equation. Now, pay attention, Mr. Pemberton. This is important. Let's remember how to solve for a variable. First, locate the variable we need to solve for. That's y. Step 2, understand what is bothering your variable. We don't want to move our variable. We want to remove the other stuff. So, Mr. Pemberton, name one thing that is bothering my y. 2 is bothering it. And Mr. Petrovsky, name another thing that is bothering my y. Nope, that's on the other side, not bothering me. The 3x. Okay, so we got the 2 and the 3x. Mr. Suarez, what should I get rid of first? The 2 or the 3x? The 3x is correct. Always get rid of the stuff that's being added to my y before I get rid of the stuff being multiplied. So, how do I do that, Mr. Suarez?
You add negative 3x.
Exactly. We can add the opposites to remove that 3x. Now, here's what I'm going to do. So that I have y equals mx plus b, I will write negative 3x before I write my 7. Step 2, I got to get rid of the 2. How do I do that, Mr. Petrovsky? Exactly, divide by the same. Now here's the key. You are used to leaving your y equals like this, negative 3x plus 7 divided by 2. If you're dividing multiple terms by a number, what you can do is divide each term by that number separately. Now, by just looking at the equation, Mr. Bladen, you're going to tell me what the slope is and the y-intercept. What's the slope of this equation? Yep. What's the y-intercept? So simple. But we got to get there, and we got to get there correctly. Now, of course, that would be the point 0, comma 7 over 2. Let's do the second one. Figure out what the slope and the y-intercept of that 6x plus 3y equals 5 equation is. sixth, right? You're not doing this?
Mm-hmm.
Okay.
You have to everybody.
Yes. You have to divide everything on that right side. And if you get negative 6 over 3, might as well simplify it. All right, Mr. Gunter, what was the first step you did to solve this equation for y? Beautiful. And then what did you write on the right side?
Negative 6x plus 5.
Perfect. And what was step 2?
Dividing by 3.
Divide everything by 3. And then when we split it up, negative 6 divided by 3 is negative 2x. 5 divided by 3 cannot be simplified, so you just leave it as 5 over 3, giving me a y-intercept at 0, 5/3 and a slope of negative 2, or negative 2 over 1. Cool. What about these two? Solve them for y so that you can find the slope and the y-intercept. Figure out what y is, where it is, what's bothering it.
So you have a fraction where that says divide by another fraction.
Dividing by a number is the same as doing what?
Multiplying the reciprocal.
Okay, so go do that. Simplify this. Don't scoff, just do it. Miss Stewart, what's the only thing I have to do to solve for y for my first equation? No? No? Don't listen to him. What did you do? You did it right. That's why I'm calling on you. Good. That's what you should do. Good job. That's it. Yeah, because you subtracted it. Mr. Maurer, do you see what we're doing here?
Well, I thought you meant finding the y-intercept.
Yeah, well, we can find the y-intercept by solving for y, right? I solve for y. What's the y-intercept? 2.
Well, you can just make x 0.
I know. Same deal. Same deal.
So that's fine.
No, you're correct. You're correct. For sure. And you get the slope negative 2/3. Well, do the other one. Guess what? You can divide fractions by a number. Same thing as multiplying by the reciprocal. Let's do that. Solve for y. No. But you could subtract 5/4 x or add negative 5/4 x. What's negative 5/4 divided by 4? Figure it out. Come on. No, multiply. 4 times 4 is 16. You can do that. That's all right. But no, can't do it. You got to multiply everything by 4. this is flipped. This stays as 5/4. 5/4 times 1/4. No, you just flip the 4. Did you solve for y? Solve for y. Give me the equation as y equals. No. Try this again. No. Oh, guys. All right, let's walk through this one. Everybody watch, because 2/3 of you got this wrong. Add the opposite to get rid of the 5/4 x. That leaves a negative 4y, which is equal to negative 5/4 x plus 8. Hopefully, so far, so good. Step 2 is to divide by negative 4. Now, we're dividing everything by negative 4. Make sure that negative doesn't disappear on you. Giving me y equals, I need to figure out what 5/4 divided by negative 4 is. I know that 8 divided by negative 4 is negative 2. That's my y-intercept. 5/4 divided by negative 4 is the same as 5/4 divided by negative 4/1, or negative 5/4 times 1/-4. Multiply by the reciprocal is all you have to do. This ends up being negative 5/-16, which is positive 5/16 x. Okay. So we have to be comfortable solving for y. Remember, moving forward, since we have this knowledge that a form of y equals will give us information, as long as we can solve for y, this information is just visually seen. It does not have to be discovered like we did here, here, and here. Well, also with this powerful information of this y equals mx plus b form of a linear equation, I can give you the line. And you can give me the equation that produces all of those solutions. I know, it seems crazy. Usually we are given equations and we produce lines. We can be given a line and produce an equation. Figure it out. If that is the line, what's the equation? If that is the line, what is the equation? Yep. Careful, you're running 2 there. That's how you simplify this. You're not running 1. Just leave it as 2. Just leave it as 2. All right, Mr. DeSimone, what is the equation of that line? Perfect. This equation will produce all of these solutions, including these two that are given to us. This top one telling us what our y-intercept is, and the top one combined with this other one telling me what my slope is. My y-intercept. This is my y-intercept. This is my slope. I just took a line and produced the equation of that line. Up 4 over 2. Up 4 over 2. 4 over 2 is 2. Now let's do this one. We'll see. Let's see if somebody can figure this one out. I'm given 2 points, -3, 2, and -2, -2. Those are a point. And it looks like I have a y-intercept down there. Well, Mr. Blaine, what'd you get? Let's see. The slope between these two, I go down 1, 2, 3, 4 over 1. So the slope is definitely -4 over 1, which is -4. Mr. Bladen says y-intercept's got to be at -10. Well, if this is true, -3, 2 should work in this, right? So let's check. 2 is equal to -4 times 3 minus 10. 2 is equal to -12. Sorry, this is -3, so it's positive 12 minus 10. 2 is equal to 2. Boom. I have to check to see my equation's actually right. Let's see the other one. Y equals -4x minus 10. I got -2, -2. I got -2 equals -4 times -2 minus 10. -2 is equal to positive 8 minus 10. -2 equals -2. We got it. Though it doesn't look like it, it is. Well, if these 2 points work, then this has to be at -10. Graph's a little deceiving there. I just wanted you to know that you'd have to make sure that your equation works with the points provided. Okay? Well done, Mr. Bladen. The other ones will be a little more obvious, though, guys, except for this one. Why don't we do this one? Yeah, figure it out. That y-intercept is obvious. The y-intercept's at -3. Figure out the equation for this line. No. I'll give you the points, 1, 0, and 2, -5. That's the point. That's the point right there. 1, 0, and that's 2, -5. What you'll find out in the future is that we'll have another version that'll help us not have to, like, guess. Miss Noha, what is the equation of my first line on the top left?
5 to the 3 6 x plus negative 3.
Perfect. Up 3 to the right 5 is my slope. My y-intercept is at negative 3. What's up, Mr. Cross?
Negative.
No, definitely the y-intercept is not at 10. Okay, let's do the one on the top right. There are ways to make sure you know where that y-intercept is. Exactly. I won't give it to you. You have to figure it out. So the y-intercept's at negative 5. Doesn't look like it. So this is up 5 to the right 1, because you have positive 5 there from your slope. So the y-intercept's at negative 5.
There's a dot right there.
What, right there?
No, right there.
Yes. Is that my y-intercept, that dot?
Uh,
What is my y-intercept? Point to it. It's right here.
oh, yeah. Oh.
That's where the graph crosses my y-axis. Is that at negative 5? Careful with your slopes. Careful with your slopes. There'll be an equation for it. We'll have to talk about that. So you're telling me that the y-intercept's at 10? That's all the way up here. Rise of 1, run of 5. Rise over run. Mr. Ard, what'd you get? 5 for the y-intercept. What's the slope? That's exactly right. Now, how can you figure out and make sure that that y-intercept is indeed exactly at 5? Yeah, use your graph. That's probably what we should have done last problem too. If we know we go down 4 over 1, let's keep going down 4 over 1, down 4 over 1. Boom, that gets us to negative 10. Here, we know we're going up 5, left 1. Well, let's go up 5, left 1. Boom, gets us to that point 0, 5. Up 5, left 1. Up 5, left 1. There's our equation. Okay? Now, won't always work out. Sometimes the y-intercept will be at a decimal, but we get the right idea. Okay? What about this one? Everybody do that one. What's 0 times x? Yes, not x. Ms. Schlegel, what's the slope of that line? 9 is not right. That's the run. What's the rise? Okay, rise over run, everybody. Remember, it's not just a run. It's not just a rise. It's a rise over a run. Up, none, to the right, 9. Now, simplify that, Ms. Schlegel. What's 0 divided by 9? 0 is correct. You're allowed to divide a number into 0. You're not allowed to divide a number by 0. So that's the slope. What's the y-intercept, Ms. Schlegel?
0? Or wait, no, 9.
Where does the graph cross the y-axis? At 9?
No, at 0.
At 0?
Or at, I don't, sorry, I'm sorry. Negative 2. Oh, at 2. -2.
Exactly.
Yeah.
It's okay. So, my equation, y equals mx plus b, is just y equals -2. One simple. Well, this slope is what, Mr. Petrowski? Is it 0? This slope is 0. So we got a rise of 1, 2, 3, 4, 5, and a run of 0. You're not allowed to divide by 0. All right. What's my y-intercept, Mr. Pemberton? I do not have a y-intercept. Well, that means y equals mx plus b is not going to work. But there's still an equation for that line.
Oh, x equals
B plus MX.
That's it. X equals -4. That's a vertical line.
Why would it be -4 whenever all these are answered?
Because remember, Mr. Cross, remember, Miss Wright, that if I have just one variable, I can always put 0 times your other variable.
Look where it's at.
All of these x coordinates are -4. -4, 3. -4, -2. No matter what my y is, x has to be -4. Okay? Don't worry. It's the first time you've seen guys like that. Do the next two. Shh. Shh. Simplify your equations all the way. Good. You don't even have to include that. Do this one. X squared? Can you simplify that at all? Make it look a little nicer? Don't forget the X. Don't forget you're rising and running, and the directions count. Miss Newton, what is the equation of this line on the left? Good. And what did you get for this one again? Perfect. The slope is down 4, right 4, so that's -4 over +4. You could have gotten 4 over -4. That can be simplified to be -1. The y-intercept is at 0, so instead of writing y equals -1x plus 0, just y equals -1x, or y equals -x. Whatever you want would be the equation of that line. Mr. Sharma.
It's also the second most common slope along.
I won't say it's most common, but what is the parent function? Exactly. Y equals x is the simplest form of linear function that we talk about. This would be like the opposite of the parent function. There's no simpler one. Y equals x is what we consider the parent function, the original linear function that we can compare all other linear functions to. Miss White, question? Yes, y equals x. You will need to know, but we will discuss it more when we talk about transformations. All right, guess what? We are done, and you get to do your homework. So grab a book at the back of the class. I'll put the homework on the board.